Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is the second periodic property, that is ionization energy or ionization potential. Children, we all know that out of metals and non-metals, who has more tendency to lose the electron? Obviously it is what, children? Metals. Children, to make you understand the definition of this ionization energy, we'll consider one simple example. Sodium, right? What is the electronic configuration of sodium? It is 281. Now, will it lose electron or gain electron? Obviously, sodium is a metal, it will lose electron. Which electron it will lose? The electron present in first shell? No. Second shell? No. The electron present in what shell, children? Outermost shell. Now, after the sodium loses electron, it will form what, children? Na plus, right? The electronic configuration of Na plus is what? 2,8. This Na plus is called as what type of ion? It is called as cation. What is a cation? See children, it's very easy to remember cation. Cation T looks like what, children? Plus. Cation is the one which is having a positive charge. Now children, how many sodium atoms you have taken? 1. So that's why I will call it as what? Isolated, right? Now, before sodium lost electron, do we have any charge on the sodium? No. I will call it as what? Neutral, right? And one last question, children. See, I have a solid sodium, right? And I have a gaseous sodium. In which state sodium will easily lose the electron? Obviously, it is in what state, children? Gaseous state. You know exactly how this process happens. So first, what I will do is that I will heat solid sodium. It will go to the what? Gaseous state. And in gaseous state, it will lose that electron which is present in the outermost shell. And it will become a what, children? Cation. That is Na plus. Now, whatever the energy you are supplying, right, during this process, that energy we call it as what, children? Ionization energy. Sir, then what is the definition of ionization energy? First, ionization energy is nothing but amount of energy required or supplied. For what purpose? Amount of energy required or supplied to remove the what, children? Outermost electron from what? Isolated, no charge, neutral. In what state you are removing? Gaseous state. After removing what it forms? Cation. I repeat, what is the definition? Ionization energy is the amount of energy supplied or required to remove the outermost electron from a isolated, neutral, gaseous atom to form a what, children? Cation. Now children, this ionization energy is going to depend upon what factors? Children. Children, one simple question actually. Observe here. There are two factors which is going to affect ionization energy. Out of that, one factor is something like this. Observe very carefully. If I hold like this, as usual, you know, this is nucleus, and if I hold like this is the outermost shell containing electrons, right? This is one atom. Observe the size of the atom, right? And this is one more atom. I repeat, this is atom 1 and this is atom number 2. Now, common sense says that out of 1 and 2, which is the bigger atom? Atom number 1. You are right. Now children, see, the same atom 1, I will write it on the board. Right? This is atom 1. And the same atom 2 I have written here. Now children, I want to remove the electron from both the atoms. Use your brain and tell me, to remove the electron from atom 1 I have to supply more energy, or to remove the electron from atom 2 I have to supply more energy. Tell me. Children, in atom 1 what happens is that the distance between the nucleus and the outermost electron is more. When the distance between the nucleus and the outermost electron is more, then the force of attraction between these two will be More or less, children? It will be less. Sir, on increasing the distance, why the force of attraction between nucleus and outermost shell will decrease? It's very simple. You already know, children. We have discussed in our previous videos. See, the electrons present in these shells, right? These people will act as a barrier or a screen between the nucleus and the outermost shell containing electrons. The effect caused by these people, we call it as what effect, children? I think we have already discussed this one. It is screening effect. Because of the screening effect, right, as the distance increases, the force of attraction between nucleus and the outermost electron will be less. When the force of attraction is less, obviously it is easy to what, children? Remove the electron. That is, the energy what you need to supply to remove the electron is less. That is, ionization energy is less. Okay, now come to this case. In this case, the distance between the nucleus and the outermost electron is what, children? Less. And here also, and here one more thing is that the screening effect, that is, here how many screens are there to block these two? 3. Here how many are there? 1. Obviously here screening effect is also what? Less. So, because of the less distance, the force of attraction between the nucleus and the outermost electron is what, children? More. Now, when the force of attraction between these two is more, then to break this force of attraction, obviously you have to supply what energy, children? More energy or less energy? Yes, obviously it is more energy. That is, the ionization potential is what? Or ionization energy is what? More. That is, the first factor which is going to affect ionization energy is what, children? What is this? Size of the atom. That is, atomic radius. Greater the size of an atom, less the force of attraction between nucleus and outermost electron. So, the energy what you need to supply to remove the electron is less. Smaller the atomic radius, the force of attraction between nucleus and outermost electron is more. To break this force of attraction, you have to supply what? More energy. So conclusion from this one is, what is the relationship between atomic radius and ionization energy, children? Right? What is this relation called as? Inverse relationship. That is, atomic radius is something like this, right? As the size increases, the energy what I need to supply to remove the electron is what? Less. As the size decreases, the energy what I need to supply to remove the electron is what? More. Then what is the next factor, children? The next factor is nuclear charge. Children, as the nuclear charge increases, that is, as more and more protons are there, the electrons in the outermost shell are held with greater force, or there is a more force of attraction between the nucleus and the electrons present in the outermost shell. Then obviously, to remove the electron, you have to supply what, children? More energy. That is, as the nuclear charge increases, the ionization energy also increases. Why the ionization energy increases? Again I am telling, because the force of attraction between the nucleus and the outermost electron will be more. Okay, so these are the two factors which affect ionization energy. Now children, though both the factors are going to affect ionization energy, but children, for our convenience, if you ask me out of these two, which is the main factor, I'll tell definitely atomic radius. Children, to understand the concept in a very simple way, we will consider only which one, children? Atomic radius. Okay, now we will see what is going to happen to the ionization energy when we go across the period. Children, before I write the values, I am telling you again, these values, whatever I am writing, just to make you understand. This is not important for the board exam, right children? Now lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and what children? Neon. Configuration is 2-1, 2-2, 2-3, 2-4, 2-5, 2-6, 2-7, and 2-8. Okay children, so let us see the ionization energy values or IP values of all these elements, right children? Children, before I write the values, one simple question. Just now I told that ionization energy and atomic radius, how these two are related? Yes, you are right, inversely proportional. Now, across the period, what will happen to the atomic radius? Yes, decreases. That is, as the atomic radius decreases, what should happen to the IP? IP should increase. Now we'll see whether it is increasing or not. Okay, children? Now, look at the values. It is 5.4, okay, 5.4 electron volts children, that is ionization potential, okay, beryllium 9.3, 8.3, 11.2, 14.5, 13.6, 17.4, 21.4. Ha children, observe the values very carefully. What is happening to the IP values across the period? 5.4 to 9.3 increase, 9.3 to 8.3 decrease, okay, 11.2 increase, 14.5 increase, 13.5 decrease, 17.4 increase, 21.4 what? Increase. Sir, sometimes increases, decreases, something like that is happening. So children, what we'll do is that we will not consider these two. Which one? Beryllium and nitrogen. Actually, these two, right, we will discuss in the next videos. Now, if we are not considering these two, right, this to this increase, this to this increase, this to this increase, 13.6 to 17.4 increase, 17.4 to 21.4 increase. So, across the period, the ionization potential or ionization is going to what children? Increase. Now, what is the reason for the ionization potential to increase? Children, across the period, this is lithium children, this is lithium, across the period, the atomic radius is what? What children? Decreases. As the atomic radius decreases, the electrons in the outermost shell are pulled with what? Greater force. And if the electrons are pulled with greater force by the nucleus, then to overcome this force of attraction, the energy what I need to supply to remove the electron is more. That is, it is going to what? Increase. And also one more thing is that across the period, the nuclear charge is also what children? Increasing. So conclusion from this one is that across the period, the ionization potential increases because of decrease in the atomic radius and increase in what? Nuclear charge. Now, one simple question. Out of all these elements, which is the element that is having minimum ionization potential? Obviously, it is what? Lithium. Then, which is the element that is having maximum ionization potential? It is what? Neon. I hope neon is having a what structure? Octet structure, right? Now the question arises, why neon's ionization potential is maximum? Reason is very simple. Sir, it has got a completely filled electronic configuration. What is the configuration called as? Octet, right? So because of this octet configuration, it is already stable. So to remove the electron from this stable atom, you have to supply very high amount of energy, right? So why the ionization energy of lithium is very low? Because of its bigger what children? Size. Bigger the size, energy what you need to supply is less. Smaller the size, the energy what you need to supply is what? More. Okay children? So this is how the ionization potential varies what children? across the what? Period, right? I think you have understood this one. We'll stop here and we'll continue in the next video. Thank you, children. Namaste, everybody.